Hello friends, welcome to our website etltestingtutorial.com. Today I'm going to start with all of these topics, that what is normalization, why we do need that, and what all are the different types of normalization and how denormalization is required within data warehouse. Okay, so we'll discuss about mainly the normalization. So what is normalization? So before jumping on to the topic, let me show you the example. In the previous sessions, I was discussing about the complete details of SQL, right? How the constraint works and what all are the clauses within that, and with the referential integrity or with the different types of joins and stored procedures, we were totally able to write the queries inside that, right? So now the next session is going to introduce with that how we decide the schema. Like I was saying that within the database we have the tables, we have the views. Within each and every table we have the columns, right? So how to decide which one column we'll keep within our table? Like if I take the example of the retail store, within retail store we have the category table, we have the product table, and the sales table, and the regions table. And within category table, if I take the example of a single table category, within that we have cat ID. We have already worked with these things. We have the cat name and the quantity inside that, and the number of the price for that, right? And in which location it is being sold the most, and the list of all the places, right? This is the one of the example. This is for category. In the same way, we'll have the columns for the product, for the locations or the regions, and we have the table as orders. Now the thing is how to decide what will be the column name, how to decide which all tables will be present inside that database category or the product or the locations, right? These all are very important to decide to work with within the retail store, within the not only for retail, for any of the database. And after deciding the name of the table, what all will be the column names, which all columns will keep, which all columns, or what all will be the data type. These things can be decided with the help of the normalization. So the main reason of working with the normalization is to keep the data in a good manner that will be more readable, or I could say that more consistent and less redundant. Redundant here means duplicacy. We should have less duplicate data, or it's more readable, and the more consistent, like integrity should be maintained. These are the few reasons of working within the normalization. Now how to decide what all will be the columns, like if it is wait a second, if it will be a primary key, or if it will be the not null values inside that. So on the basis of which details will decide these things. These things again comes with the, within the normalization we have some more concepts, like on the basis of different levels we decide what all will be the constraints on that particular table. That is 1NF, 2NF, 3NF, BCNF, and 4NF. Like this it works at 5NF. So these all are the hierarchy inside that. And the main thing, if we are dealing with 3NF, make sure that your table is in 2NF as well as within 1NF. This is how it works. So to achieve any higher level within the normal forms, make sure that all of the lower level normal forms are achieved. All of the levels under that should be achieved. Okay, let me keep it like this. If it is BCNF, then it should be in 3NF, 2NF, and 1NF. Like this, we need this. Okay, so now let's see what all are the requirements within 1NF, 2NF, and the other forms of normal forms. the other levels within normal forms. Okay, if I use this, okay, these all are the topics. And with the normalization, this is the complete definition: to keep the consistent data, to maintain the integrity within that, and to maintain the accuracy and to remove the duplicacy. We work with normalization. Okay, and within 1NF, let's see. So these all are the definitions. I'll show you the examples how to work inside that. Okay, so before jumping on to the example within NF, 1NF or 2NF, let me show you what all are the problems that could come if we are not dealing with the normal forms. Why do we need actually to jump on to the normal forms? Let's take this example. So in this, these all are the record set of let's say if it is the record set of any class for the students: Adam, Alex, Stuart and Adam. So Adam, the name of the student, have opted bio, and Alex maths and physics. Adam, so Adam have opted two different subjects, and these are the addresses. So if we look at this data, I can say that Adam is the one who has opted two different subjects, and the Alex and Stuart have opted single subjects, and the location inside that. Now let's say this is the data within the database. So now let's say if I want to update the record set for the Adam, like from Noida, he has shifted to the Delhi instead of Noida. I just want to update the location, update the address of that student. So I don't need to update this detail within the two records, this one and this one, because this is coming twice. So let's say this is the two time, let's say 1,000 such records are present with the same name. So every time we have to update the complete record set for that. This is for the updation. Now let's say I want to insert a new record set. Let's say if I insert the ID for that, a new student is 405, and the name of that student, let's say Joy, and the address of the new student as Delhi, and that student has not opted any subject, so the subject I'll keep as null. Right, so this is what we'll do. So every time when a new student is coming, is joining that class, we have to mention the subject that is being opted by that student, but maybe he haven't decided yet. So this will be the problem. Every time we have to come with the decision, like this is the subject that will be opted by the Joy. Or if the subject, while creating this schema of this table, we have kept the subject oriented as a not null value, as a constraint on that particular column. So it is again a big problem. Insertion will again create some problems. Now what about deletion? Let's say the Alex, or let's say the maths, in that class, maths is the one that is not going to be uh, like teach anymore. So maths will be deleted from the record set of the subjects. So this will also be the details of the two students will become null and null. So again the problem, let's say again the subject oriented, that column, the constraint on that column is as not null. So how can we keep this? It's again a big problem, right? Or let's say instead of maths, if I take one more example, if Adam chooses to, in the second way, if I look at the same problem, if Adam has discontinued that class, okay, Adam is a student that he don't want to continue anymore in that class, so for that cases, Adam I'll delete. So from two places Adam will be deleted, so this complete record set will also be deleted. Right, so this bio subject will exist, but with the address value as null and the name as null, because the one who has opted that bio and physics is not working anymore, is not in the class anymore. So these all are the problems. To overcome these problems, we can work with the different normal forms. that we need to work, right? As every time while storing the data within database, we don't want to keep any such value that could create a problem while doing the updation operation or the insertion or the deletion operation. So every time when we are working within database, it should follow the normalization, the different levels within that at till which level the normalization is being supported within that database, this will be decided as well while creating the schema of that within that database. Okay, now let's see again the first normal form. I'll explain you with this example. So first normal form says that for every column value, like let's say if this is the example, Adam is the one, age is 15, and he has opted two subjects, bio and maths, bio or physics, like this. So in this case it's bio and maths. So we can't keep multiple values in a single column, bio and maths. Right? This is like we can't keep both of the values in a single column. So what we'll do, we'll make a separate column for both of the values within that particular, for that particular that record. So the complete record set, each and every record set will contain a single value. We can't keep multiple values in a single column. This is the first condition with a normal form. As well as the within normal form, there is one more thing. Every time we must have the primary key. So what do you mean by primary key? If I take this example, inside that John state three phone numbers are linked. Right? So within that, we'll keep every phone number in a new record and we'll store a different ID for that. This ID is a primary key that is not null constraint as well as the unique value. If you don't know how to set the primary key and how primary key works, you can refer module number 3, part number 4th, I think, video you can refer. Okay, so this module covers the different constraints inside that. So the primary key should be there as well as we can't have multiple values in a single column. This is for the first normal form. Now the second normal form, if I take the same example within this, or let me show you from the SQL server. Wait a second. First normal form I'll explain first. And this is the example that I have already kept with me. Okay. Let's create a database with the name as SAM. And how to write these queries we have already covered. And then I'll use that sample database and then I'll create a table. Wait a second, I'll tell you what I'm doing. And these all are the values that I'll insert. Right, so now let's write the select command within that. Select star from customers and wait a second. So within this table, if we look at, we have 4 different records with a single name, a single person, Abhishek Kumar, with this age from this city, have opted 4 different courses: ETL, Selenium, JMeter, and Hadoop. Right, so 4 different courses for by a single person with the details are same. How can I say this is the same person? Because the record set is same. So this is something that is not in 1NF. I can also write the same thing in this way. Both have the same meaning. ETL course or Selenium, JMeter, and Hadoop. Right? So 4 different courses in a single column value. So if this is the case, firstly we'll keep every record within a new line. Right? If this is the case. Like this, that it's already like this. And the next thing, we don't have the wait a second. This is the first thing that we'll do. That's already in this way. So the next thing is we'll add the primary keys. So how to add the primary keys? How to convert this table, this existing table into the one NF form? We'll divide this table in two different tables. First table will come with the record this one, Abhishek, 36 Bangalore, and the next table will come with this details, as well as the primary keys will also be added. Right, so the table is already there. Let me create, and if I execute, and then if I insert a single value inside that, now let me write the query. So the first table will come with the details of the customers. If we have multiple, then we'll keep multiple. So only one record we have, the ID is 101. Right, so now we'll work on the subject, on the order that he has ordered. So if I execute, I'll create a new table, and then I'll insert different values inside that. 1 rows, 4 rows affected. And now I'll show you the table. Orders 1NF. So within this orders table, or let me write these both queries, I'll run simultaneously. Okay, parallelly I'm running, so that this is what I'm getting. So 101 is the Abhishek with the name, age 36 and address, and this is for the first table, that is customers. The second table is coming from the orders NF, 1NF. So this is the ID for that subject, ETL, and the ID that who has opted the subject. I can also here I am using the same name for the ID of the customer and the ID for the customer within the customers table and the orders 1NF form. So this is how we can keep the details. This is for the, this is the all of the values. Here we don't have any of the insertion value, insertion anomaly or the updation anomaly. If a new person is coming, so a new customer is coming surely, so we'll store this thing within the 102 ID with the name, let's say Vivek, with the age 33, and from the details Pune. Okay, a new person is joining 103, like this we'll keep. In the same way for the subject, I'll write if he is opting the same subject, so we'll write but the ID will be different, right? So 105 we'll keep for the ETL course with the ID as 102 who is opting that subject. So this is a new record set that we are keeping. This is for first normal form. So we have the primary keys as well as we have a single record value within a column. This is how first NF works. Now about second NF, wait a second. Okay, second NF says, or if we take this example, employee name, employee age, then we'll divide it into the employee ID, employee name, and employee age. We'll just add a new column as primary key. Every time we don't need to split our tables. It may be conducted within a single table. It may be done. It may be fulfill the requirements, fulfill the conditions of that particular NF form, normal form, right? So now what about second normal form? She says that we don't have any partial dependencies. Like if I take the same example, or let me show you. Okay, so this is the table. We have the table Adam with the age 15. Let me go to this. So one more thing. If I'm discussing about 2NF, so it means my table is already in 1NF. So I'll use the resultant of 1NF to work within 2NF. So this is my resultant of 1NF. So I'll keep it as a source table for my 2NF. See, in this table, Adam is with the age 15 is opting the bio subject. This is the detail of that Adam student. So Adam age is 15, this is linked. Adam is opting bio, this is also linked. But is any way link between age and bio? No, there is not any link. So it means that there is partial dependencies between age and subject, and we'll remove these partial dependencies by dividing this table in two different tables. First table will keep the details of student with the age, and the second table will keep the details of the student and the subject that he has opted. This is what is being explained. Adam with the age 15 and Adam is opting the bio subject. These are the details that are linked. Or if I keep this, and a second example that I was using to explain 1NF. So after implementing 1NF, we were getting this resultant table. So in this resultant table, what we'll do, if you look at name is linked with the phone number, like this is the name and this is the phone number, and the country is this one. But is any way link between the country or between the state and the phone number? There is not any link. So what we'll do, we'll divide this on the basis of ID, name, state and country. ID, name, state and country, this is the first thing, and second will come with the ID, name and the phone number. ID, phone number and the phone ID. Phone number and the ID that is coming from here, the primary key that I'm using. Okay, so this is how second NF works. Now what about third NF? If you look at third NF is something that removes the transitive dependencies. So now what about transitive dependencies? If you look at the same example, this one. Student ID, it's a different example. Student ID, student name, date of birth, state, cities, and the zip for that city. So in this table, we are using the concept of the third NF surely. So student ID, subject name. So the date of birth is linked with the name of the student. That's correct. And out of these four, like street is dependent on the city. Within city, like within state we have different cities. Within city we have different streets. And zip is again linked with that particular city. So here is more than two links are present. Right, so we'll keep zip, street, city and state in a different table, and we'll keep ID, name, date of birth and zip in a different table. So this is how transitive dependencies are removed. Right, that's all for all of the three normal forms that we have. And now what all are the difficulties with the normal forms? Like what all are the problems? Like within normalization we are dividing our data into multiple tables, right? From the, as I said, for the one NF I choose the customers table, then I create the customers 1NF, then I create the orders 1NF, right? So in the same way that was for the first normal form. Again we'll have for second normal form, we are going to increase the number of tables, so more tables we'll have, and that will degrade the performance as multiple tables are to be linked, that will be executed, so it will create more problems while working within the databases. So problem is the biggest issue while working with the normalization. And with the denormalization, let me show you the same example, the very first one that with which I started, the anomalies. See, if this is the table, if this is the data that we have, I want to have the details of Stuart. So Stuart, the details, Stuart is living in Jammu and he has opted math subject, and this is the ID or the roll number of that student, if I'm taking it as a student example. So in that case, fetching the data is very easy. Surely we'll have some anomalies, we'll have some of the duplicate data like Adam Noida. So the performance is not at all is an issue inside that. Only with one problem, we'll lock that table. Like we can't update includes insertion, deletion while working with that. So denormalization means without multiple tables, we'll store all of the details in a single table. That will increase the performance. That will give us good response time. Response time means how much time it is taking to give us back response. Right, so normalization is the one that works within our dbms, and we have, as I was saying, it makes our data more readable. Like if I want to talk about customers, only the details of customers are able to read, not the details of the orders that are being ordered by that customer. It will remove the duplicacy, it will make our data consistent, but the performance will be degraded, so we don't need this. So the analysis can be done within denormalization very easily, very useful. Right. So that's all for the differences between normalization and denormalization. In the next session, we'll start with the dimensional modeling and the architecture of the data warehouse.